Oh, hello everyone. Yeah, welcome.
Can
Oh,
you can hear?
yeah, we can hear. Yeah.
Oh, good. Yeah.
Oh, oh, mm, okay. Hello everyone. Nice to see you guys here, and welcome to SGLang's after Christmas party. Okay, so today we have a lot of things to talk about, so each part will take only a limited time. If you have any question, please type it in the chat or directly ask us. And thanks so much. Right. And yeah. Also, so today the first topic for us is integration with RL training frameworks with SGLang. I make a quick, yeah, I have quick slides for this, right? Let me share that. Okay. Oh, okay. Sorry. Yeah, wait me a second. Okay. Yeah. Could see, right? Okay, so yeah, thanks for everyone for coming. And today, the first topic for our talk is about the integration between SGLang and the popular RLHF frameworks, and we will have a lot of incoming collaborations. Let's us dive into that, right? So. To give a quick context, why SGLang is needed in these kinds of RLHF frameworks. So, if you're not familiar with PPO, so here's a picture about how PPO works. Basically, you start with a prompt and you give that to an actor model. The actor model could be whatever model you want to train on, like the Llama 3.18 billion base model. So you you send in the prompt to the actor model, and the actor do inference on the kinds of model and get the response, and then you take the responses and concatenate the prompts and the response together, and to go through several of these models like the actor, somehow the online the somehow the actor in the training engine, and also have the reference model, and so on. So go through this part, and ultimately you will get three key values. The first is the KL diverge, and the second is the return, and the last one is the advantages. So I won't dive into any of these kinds of computation, but this picture gives a clear map is that we have two um, this picture gives a clear map that we have two actors in the whole training framework of sorry, I don't know what happened. Let me check. Okay, so okay, the clear thing is that we have two actor model. The actual model you want to train in the whole pipeline. One is purely doing inference, and one is in the training engine, and that will be weight updated. So each time you can see that every time for every rounds of for every epochs, we will give several prompts to the model, and the model get the response and take the response and prompts into the following pipeline, and we update the actor model and the critic model. And after the model being updated, we will send the model back to the inference engine again and to do prompt and to generate on that prompt and get the same thing and for several epochs, like for 8 or 10 epochs. So we see the training engine in the whole pipeline just need to do one thing. It just needs to generate responses for these kinds of giving prompts. So that's really natural for SGLang to do, right? We are actually in excellent in speed and both the accuracy. But the thing could be tricky is that every time the actor model in the training engine should be updated, and you should use the updated model to do the next batch of generation. That's why we call this online RL algorithms. Okay, so continue. Here we see that the only difference is that the weight of the inference engine should be updated every round after the model is actually being updated, right? So we need two API for this. The first thing is that we need to initialize the wait update group to facilitate these kinds of updates. And the second thing is that we can directly use torch distribution to update the weights directly from the training engine to the inference engine. We have described the ideas maybe several weeks before, so I won't dive into that. But we already have implemented for over a month, and right now uh, we have integrated this into the Open RLHF framework. So I have done this right now, and we are finishing the documentation and the benchmarking the performance of SGLang engine into these kinds of framework. Yeah, so that what we already have. Basically, we implemented these kinds of with updates algorithms, and right now we support OpenRTF fully. But there's definitely more thing we need to do, like for any kinds of RLHF algorithms. They need various forms of rewards models. So we are trying to support these kinds of rewards requests. And also, uh, researchers from another group, the VERL team, they propose that maybe we can set SGLang into SPMD, um, somehow a methodology to launch the engine rather than a single controller. So, yeah, the thing could be that single controller is proved to be worse than the SPMD frame pipeline. So maybe we change that into SPMD, though this may not be that easy to use for beginners, but that would be definitely quicker and easier for them to integrate into their VERL pipeline, right? So that's what we already have, and that's the progress. So in the following 2 weeks, we will release the SGLang version into OpenRTF, and OpenRTF is a popular RLHF framework and be having more than 3,000 GitHub stars, and that's really amazing since they are just a lot of researchers in their company and they are doing OpenRTF just on their part time. I mean, at
啊，
their later time, right?
你说啥？
Hello. Oh, hello. What's up? Yeah, okay. So yeah, that's the thing I have. That's the thing what we've done for the RLHF framework integration of SGLang. So coming up, we definitely have more things to share, right? The most important thing is that we are calling for collaborations. SGLang team and together with the whole LMC's organ group will have more in-depth integration and collaboration with these two frameworks. And I think this will actually somehow give a whole bunch of purpose of RHF. For OpenRHF, as I've said here, it's a lightweighted RHF framework, and that benefits a lot of researchers. They can quickly rolling out their academic ideas on alignment and to test that. Yeah, and we will also integrate into VRL. I guess that a lot of you guys maybe do not know this kind of thing. So let me state here, VRL is an efficient and productive ready RL training frameworks that have already support the production development of several corporations. So uh, uh, anyway, if you wanted to make a large scale RLHF training pipeline and maybe turn that into production, maybe VRL could be better. But for OpenRTF, if you have some quick ideas like changing several of the weights or the loose of the PPO algorithm, it's pretty easy for you to implement that into OpenRTF and launch your engine. So either way, we will support these two frameworks and give the community the state of the art RLHF pipelines we already have. Yeah, that's what we will do in the following days. So, yeah, that's all for my quick talk. Are there any questions about these two parts, especially for the RHF pipeline?
Sorry, I want to ask you. do we have a the entire evaluation pipeline for the online PPO?
Okay. Sorry, you mean evaluation pipeline for the model after PPO?
Yeah, it's for the whole PPO pipeline because we've doing the research. We need this module to get better evaluations and yeah.
Okay.
So
Oh, okay. Yeah, thanks for the question. So, maybe how to evaluate a PPO model is separate from what about the training pipeline, right? In the training pipeline, you can always watch on the metrics like the loose, the KL diverge, and these kinds of things to make sure that your training is going well. But for the actual performance, I think is pure evaluation work. So maybe you can turn on other benchmarking works and to see how they evaluate the model. Am I saying the right thing you are referring to?
uh, um, not that much. Maybe we could talk later. So
Yeah. Okay. So, regarding the evaluation and how to monitor it in the training pipeline, right now for OpenRHF, we can just say the training metrics like the loose and the KL diverge, but actually we all know that this kind of thing is limited. So in the future, we will definitely collaborate with them to add these kinds of in inner epoch evaluation, like to run some benchmark for this kind of thing. So maybe that could also help. If you are interested in this part, you can call us and we can come to collaborate, right? Yeah.
okay. And the second question is that you mentioned your project is more faster than the VLM, right? So we use the OpenRLHF mostly in the re and the VLM. Do you have some compared performance versus re VLM?
Um,
That's my second question.
okay, so so what we already have is that we are still benchmarking OpenRHF in a realistic usage. We have do some unit tests like running OpenRHF for just 10 minutes and benchmarking the performance and the loose metrics. There's no we think that we are steadily closer or better than the VRM with OpenRHF. Yeah, but the detailed benchmarking, like running OpenRHF for over 100,000 examples, I mean prompts, and for more than 10 hours of training, we are still working on this. So this kind of report will be make in the following week. Yeah.
So sorry, you meaning that you compared the loss metrics and but for the training epochs time you've been working on that, is that right?
Pardon?
Uh, Actually, I'm more focusing on the training time cost, because when we training a PPO, maybe we use the A100, we need 27 hours to training the PPO, and if we need use the deep speed, it may cost us 37 hours. So wondering whether you in this work to use the your engine to maybe yeah, that's my question actually.
Okay. So the thing that in your utility that most of the time is taken by training rather by the inference, right?
Yeah, yeah. In my scenario, is more like training
Okay.
use the
So
VLM. Yeah. So
Okay, so in this kind of scenario, although personally I do not ever have this thing actually happen because most of the time we are spending on rolling out. I think that if the training engine is taking most of the time, maybe the benefits of integration SGLang into OpenRHF is marginal. But for the whole OpenRHF project, right now using DeepSpeed and a lot of researchers they are suggesting maybe we can use BPS or maybe I use FSTB or Megatron, this kind of thing. I think this could be better. And there's definitely several people working on this. Yeah, it's undergoing. Yeah, I hope you will find more issues and related things on the OpenRHF issues, right? Okay. Yeah, and so that's my part. And also for the author of VRL is in our meeting. So he said that VRL performance, there's definitely evaluation scores during the training. So as I've said, that's maybe it's a better production already training pipeline. Yeah. So that's the same for it right now. Okay. Are there any questions? Okay, so maybe we can move into something else. Yeah, we will spend the following nearly half an hour on DeepSeek model support and discussion. So let's move on for Zhang or Kabao. Are you guys here? Yeah.
Yeah.
Hey. Hey. Okay.
Let me share my screen.
Yeah.
Okay.
Okay.
Could you see my screen?
Yeah. Clear. We can.
Okay. Recently, the DeepSeek has released the DeepSeek V3 model, and it's a very strong MOE model with 671 billion parameters, and the performance is very, very good. It's very impressive, and we have supported it in our SGLang framework at the first time, and maybe you can ref this doc to use it. Yeah. Yeah, you can deploy it with 8 H200 GPUs. If you your GPU don't have enough memory, you need to deploy it with a multi-node tensor parallelism method, and you can use it with Docker and or deploy it install it with pipe. Yeah, since most of the architecture is the same with DeepSeek V2, so the previous optimizations like multi-head latent attention optimizations and DP parallelism attention is also works for DeepSeek V3. And there are many three changes for the architecture for DeepSeek V3. You can see the Hugging Face model config. The first change is about the top key method. It uses the non-auxiliary loss DeepSeek auxiliary loss top key method for load balance for better load balancing, and the main difference is it added a new parameter, the bias to the auxiliary scores. So we need to load these parameters from the checkpoint, and then it uses the sigmoid top key, the activation, the scoring function. Yeah, and in DeepSeek V2, it used softmax. So this is changes. And the next part is about the quantization config. DeepSeek V3, it used blockwise the FP8 quantization. So this part will introduced by Ying in the next part. And the third part is about the next N layers. Yeah, it's used for speculative decoding, and we haven't spotted it yet, but it's in our optimization plan. And here is our optimization plan for the DeepSeek 3 model. We have already make it compatible with CUDA graph. It can speed up the decoding for for small batches. And we also make sure the accuracy for the FP8 inference. And the FP8 Triton kernel is also tuned. and in the future, we will replace the Triton kernel with the Catalyst for NVIDIA GPU and the CK implementation for AMD GPUs for better inference performance. And we also and currently we only support DP or TP for the attention part, but in the future we will make it combinable. And yeah, we will also optimize. We will support the next N speculative decoding in the future. Okay, Yixing here. You can introduce the FP8 kernel next.
Okay.
Okay.
Can you hear me?
Yeah.
Okay. Let me show my screen. Can you see my screen?
Yeah.
Yes.
Okay. I'll show you guys some details of the kernels. Before do that, I will introduce the quantization scheme of deep scale V3. First, for the activation, they use float aids to inference to do the inference. To be more specific, they perform the activation perform for token group activation. That is, they perform quantization in one token activation, and and every 128 elements is a group. They share the same quantization skill. So the first kernel is to do the dynamic activation quantization. That is this kernel. The kernel, the key of the kernel is to reshape the activation to be the last dimension is the group size. That is this line. Then we launch many thread blocks to do the quantization in every quantization group. That is the Triton kernel. The kernel is very similar to other quantization like for token and for column quantization. So the activation quantization kernel is very easy, as they and the weight quantization kernel may be more complicated. The weight quantization is blockwise. That is 128 multiply 128 8 is a block. They share the same quantization skill, so it's very different to the per channel quantization. We have to do the dequantization in the main loop. They have two keys to focus. First, you should to load the scale of activation and the weights before the main loop. That is the three lines. Then we need to do the decondition in the main loop. That is every time you multiply two tiles, that is tile A and tile B, you have to do the decondition before they finish. After they finish the multiply. That is here. Yes. This is the two keys to focus on. Yeah.
So yeah,
I also changed another files. That is fills the MOE kernel. Actually, it also does the similar operation like this kernel. But the only difference is we have multiple exports, so the weight B is three-dimensional. That is the first dimensional is the export. So you have to add the export offsite. Then in the main loop you do the decondition like the last kernel. That is this line. Yeah. The other three kernels that I implement is do you have any question?
Yeah, thanks for in-depth introduction and the code walkthrough, and it's pretty somehow amazing, and I can imagine how you guys working on this and the hard efforts. A quick question is that when you are trying to implement this kind of thing, which part blocks you the most of the time? Since I know you guys may be working on for several weeks or even several days, yeah. What's the most difficult things for you guys right now?
Could you repeat the last sentence? I don't follow it.
Okay, yeah. Thanks so much. And yeah, if there's no more question, we can switch to the next part.
I have a few questions.
Okay.
So I think yeah, so currently you implement the whole thing in Triton, right? But I think the DeepSeek people maybe they also have some like Catalyst implementation. What's the plan here? Will we like are they willing to share all the code?
Actually, there is another student to do this with Catalyst kernels. I will collaborate with him if he have if he have some questions on the quantization scheme. Yeah. So the main work is on him. I'll do some. I'll give some necessary help if he need. and data is.
Okay, yeah. Sounds good.
Hello. So I have another question.
Okay.
So actually, I saw the DeepSeek V3. They have provided two kinds of checkpoints. So one is FP8, and the other one is BF16. So actually, I see the SGLang engine. They provided an argument that you can translate the BF16 checkpoint to FP bar inference. So my question is, so is there any difference between I directly use the FP bar checkpoint provided by DeepSeek, and I use the FP16 checkpoint and translate during my inference by the SGLang engine. So is there any difference in this two way, or are they equivalent?
Hello. I can answer this question. First, I think DeepSeek open source the weight is FP8 by default. You can use the script provided by the DeepSeek team to convert it to BF16. And I think SGLang framework both support BF16 and FP8. And our accuracy is matched with the DeepSeek result. So for your question, I think they didn't provide the BF16 default weight with the Hugging Face. You need to convert by yourself.
Oh, yeah. Thanks a lot. So I will check myself. Thanks a lot. Yeah.
Yeah, the
Okay.
checkpoint is only FP8. Yeah, because they did the FP8 training.
So will they release a model that they updated from FD8 to BF16?
What's the question?
I was just curious about this kind of thing, because later we got to go through the DeepSeek tech report, and one of the pretty important part is the is the FP8 training, right? So we can keep this, and maybe we can listen to the next speaker, right? Okay.
Yeah, sure. Just one comment, right? So basically the checkpoint API makes sense because it's too big for their full size model. AP16 or BF16 doesn't work out from almost no system can work it out. We know. Currently the checkpoint provided from Hugging Face by DeepSeek can only be loaded in AMD MI300 and NVIDIA 200 series, right? So, oh, by the way, in Chinese market, only AMD 308 can be used officially. 200 cannot be sold in China, right? Okay, thanks.
Sorry, I want to have another question that can be, do you have the plan to support the Huawei Touch NPU or yeah. Do you
I
have a
think
plan to support Huawei's engine?
yeah, thanks for the question. Maybe in my understanding of SGLang, most of the Huawei support, we do not have this kind of thing right now, but you can check one project named Deploy, and which is developed by Shanghai AI Lab, and they have specific optimization for Huawei's GPU, like the Shenzhen, this kind of thing. I guess so. Yeah, I do not think we will have the plan for the Huawei GPU, but we definitely both support NVIDIA and AMD GPU right now. Yeah.
Yeah, I have some.
You mentioned the DM Pro, right? DM Pro.
I have to let answer, right? To like, practically speaking, just like realistically, there is a hard time for US people to contribute to the company you mentioned because there's a political restriction to do so. Be honest.
Oh, okay, thanks.
You can't do that. If they found out, you might be in trouble when you're US.
Okay.
I have a last question for Chen-Yang. When would SGLang plan to support pipeline parallelism in the framework? Is there any schedule?
Okay, and are you coming from the issue I'm replying? Yeah, I'm curious about this. So, for us, since for SGLang, we most of the time we aim our framework for high throughput and industrial level serving engines. So for these kind of engines, we have fully NVLink and this kinds of high throughput connection between nodes. So we do not support pipeline parallelize them right now since we do not scenario. Hello, could someone turn off your microwave? Are there anyone speaking? Yeah, so we think that pipeline parallelism is definitely important and is of high priority, but we do not have enough people working on that. So if you feel interested, you can definitely reach out to us and we can give guidance on how to do this. Yeah.
Got it. Thanks.
Yeah. Okay, so yeah, let me check the chat. There's several chatting having here. Okay. Right. So let's move on the next part. Yeah, we can see that DeepSeek V3 is definitely popular and a lot of people are coming for this, right? So we will let our director Lian or maybe you guys to to take us to the tech report of DeepSeek V3, right? Is that?
Yeah.
Okay.
Maybe I can answer the last question again. Yeah, pipeline parallelism. I think we have someone. We'll have someone working on that. I think should be ready like on January next year.
Okay.
January next year, right?
Yeah. So like
That's great. That's great. Thanks.
Okay, cool. Yeah, thanks. So maybe we can move on to the next part, right?
Okay. Yeah. So next part, I will lead the discussion of the DeepSeek paper. I think let me share the screen. Okay, not this one. This one. Okay, sorry, I did wrong again. One. This one. Okay. Yeah, so it's a very long tech report with many components. So I think this is because this is the like SGLang discussion. So we will mostly focus on the inference and the deployment section, point 3.4. So and see how it's different from like some popular solutions outside there. So let's start with 3.4. So basically, this model is a very sparse model. So it has like 600 total parameter and only has around 40 billion active parameters for each token. So it's a very sparse model compared to other models like typical MOE model or the dense llama model. So that's why they design such a very different like deployment strategy for their model. So they deploy the DeepSeek V3 model on H100 cluster, and then I think this cluster like should be good. It with NVLink and IB, and then like the high level strategy they use is they will separate the prefilled and decoding. I think this is like a common practice on industry right now. It has many benefits, like you can control like time to first token latency. You can also use different parallelism strategy for prefill and decode. And then for prefill, I think their strategy is very different from very different from the like what we do in the open source world, in terms of like they use a very large like what they called minimum deployment unit. So for their preview, like in order to run this model, like basically you need at least 4 nodes to run the preview, and also 40 nodes to run the decode. So in order to deploy one replica, you will need in total around 400 GPUs. So that's a very different deployment strategy, and that's specially designed for their highly sparse model and the large expert parallelism. And I think this kind of strategy is mostly optimized for high throughput settings. So I think you can imagine they will think they will have a lot of loads. So they optimize for the throughput and the cost. And then they just do this deployment optimize mostly for throughput. And then they can reuse a lot of optimizations they did for training, like the special auto kernel and overlap the communication and computation. So, and basically this is how they do the deployment. And then specifically for preview stage, they will use TP4. So for attention part, they will use TP4 and DP8. And then for MOE part, they will use EP32. So I think I think this is a very reasonable design. In SGLang, we also support expert parallelism and DP parallelism for attention. But we haven't. But later we should be able to support the combination of TP and DP. So with SGLang, we can also try this this parallelism combination for preview. And then what they did very interestingly is it seems they have a lot of other runtime dynamic design to work around the load balance. This is also very interesting problem because in SGLang we also have a router, but that's a very different thing because we don't use large expert parallelism. We use a lot of large degrees of data parallelism, and then we do the cache over load balancing. But in their deployment strategy, you can think you can imagine they all run in SPMD fashion, just like training, because when you do the expert parallelism, you will do all-to-all and sync all the devices. So you need to be very careful about the load balancing. So they did a lot of things like redundant expert and the dynamic routing during runtime to make the load of each expert balanced. But I didn't see a lot of discussion among how they make how they do cache aware load balancing. So I guess so basically there is load balancing on the attention layer. There's also load balancing on the expert layer. So how do you balance this, and how do you balance them well? I think it's also something very interesting, and I don't know how they handle this. And then for the decoding phase, I think because the decoding phase will run longer, so they use more GPU. In total, they use 320 GPUs just for a single replica. And then similarly, they use TP4 and SP4 for the attention part, combined with DP80. And then the MOE part use a very large DP. So as a result, only one GPU, each GPU will only host one expert. So this also means so basically they have to do routing. So they heavily rely on the auto communication to do a lot of dispatching. So then they don't need special kernels like the group gen we used to run the Fuse MOE. So it's quite different. And basically this is how they do it. And so overall, I think this strategy like makes sense like for high throughput oriented deployment. But if we have like high-end GPUs, say if we have like MI300 or H200, then we can host the single model like on a single node. Then probably we don't need this kind of very sophisticated parallelism, because the also disadvantage of this kind of parallelism are like when a single replica, what if a single replica fails? Then you need like very sophisticated failure handling to recover that one. But if you like have high-end GPUs and you can host everything on a single node, then you can easily do redundancy, and then you use our casual load balancing. So I think this is a very different and interesting deployment strategy, but like in the context of H100, like whether this kind of thing provides huge benefit, we still need to evaluate that. And I also tested their API speed. It's actually pretty good. It's around 60 to 70 tokens per second. So consider like they are doing this kind of a lot of multi-nodes communication. I think, yeah, their inference stack is definitely very well optimized. Yeah, do you have any questions?
In such kind of parallelism strategy, would it invoke large communication overhead? Like I said, they mentioned that the overhead is negligible, small, low latency, but is it trivial or do you think it's non-trivial? Do they describe any details about that part?
Sorry, can you ask again?
So so in such kind of mechanism, I would imagine that communication overhead could be a challenge. Might be a challenge, but they said in several places that the communication overhead is negligible and not high, low latency. But I would like to ask, do you think if that is because just trivially low, or they actually need to do some work to make it low?
Yeah, they have their custom auto kernel, so they rely on that custom auto kernels a lot.
Okay, so they wrote a very efficient kernel, and so that means an efficient kernel is enough to resolve the communication overhead issue.
Yeah, so basically they do two things. The first is they have a very customized auto communication kernel, and then they overlap this with computation. So this should be pretty good for throughput. And for latency, so if their custom kernel does it well, then latency should be like manageable. And then they do like speculative decoding. So finally, the final like speed we can see from user side is 80, 70 tokens per second. So that's like totally usable. And it's like actually similar to Llama 70B dense.
Can I ask a question?
Yeah.
So I wonder if you deploy like only one expert on one GPU, would that be a huge waste on GPU resources when you do inference? If you have a load imbalancing, or if you don't do a load imbalancing, do they mention anything about that in the paper? Like how important is the load balancing, for example, in the decoding phase?
Yeah, so I think, yeah, if because they use 32 sorry
Yeah.
300 GPUs, so if there is only one request running, right, so they're definitely like very like underutilized. But I think their assumption is there will be, because they are providing this service to the whole world, so there will be like maybe a batch size like several thousands of batch size running in this case. And then they do the like dynamic load balancing strategy. So like at every expert, they will choose like how to like at every layer, maybe also every forward they will choose maybe also every layer they will choose which expert to dispatch, and then they achieve the load balancing.
So do they mention anything about what latency this kind of dynamic routing strategy added to the inference? I guess no.
Yeah, this sentence they mentioned the overhead of computing this routing schema is almost negligible.
I see.
Yeah, but I also don't know what if like a GPU fails, things like this, how they handle that.
And also another thing was that it seems there's no, for example, dynamic scaling of the instances, right? I guess. Because it seems that this kind of unit is very huge. Like, and if there is a like kind of low request, the phase of low request, then you waste a lot of GPUs.
Yeah, exactly. So that's why I'm saying it's an interesting strategy, but whether it's the best or everyone should learn from this, I think it's still debatable.
Yeah.
Yeah, it has clear advantage and also clear disadvantage.
Okay.
And yeah, I hope they can reveal more details, like how they, for example, like in their evaluation section, they didn't evaluate this one. So we also don't know like how they compare to the other regular strategies.
Maybe I can try to ask some people from DeepSeek. I know someone like working internally, so I can like probably ask them to see whether they want to release any like further details or not.
Yeah, yeah. Okay. Yeah. Do you have any other questions?
Yeah, so I have a like small question. So if we don't adopt this scheme of deployment, what is the minimum minimum number of GPUs that we need to deploy this model? For example, if I have like H100.
Yeah, if we have like the best case is if you have H200 or MI300, then just deploy one replica on one node. Then I think
8 GPUs.
Yeah, with 8 GPU, then that's good. But if you have if you only have H100, then you need like two nodes. So in this case, I think doing things like maybe like pipeline parallelism 2, and then within one node, you can do like tensor parallelism 2, data parallelism 4. Like according to your loads, you can configure tensor parallelism and data parallelism. So I think that would be a good strategy.
I see. Thanks.
Okay, cool. We have pretty close to the end of the time. So are there any coming questions for these parts, or are there open questions to the whole SGLang project? Yeah, thanks. If there's not, there are several minutes left, so I have something to update. Like, we have come to the end of the last quarter, so everyone can check our development map and to see what we have left, and we will continue building on that. And for the coming quarter, we will definitely have more interesting things to do, and supporting more models and making better optimization and even integration SGLang into much more interesting frameworks like training pipeline, right? Also, we are Also, SGLang is coming to its 1 year birthday. So thanks everyone for enjoying the project and giving us your feedbacks on our project. So we definitely want to see more things in the next year and hope you will continue to enjoy this, right? And if there's anything you want to say, please check our issues and we have people on call for that. Okay, so and we gotta make up a proposal for a 1 year anniversary for the whole SGLang project and calling for more collaboration. If any of these kinds of things could be interesting to you, please reach out to us. And if you want to develop something, we have resources for you to use. And if you want to just know how to use something, we definitely have people and they will guide you, right? So looking forward, we are definitely having a more interesting thing. And I see a repo this year says that burning in these kinds of LLM century is really amazing to everyone. So maybe that we will also say in our proposal. So thanks for everyone coming and enjoying today. And we got see everyone later. And record will be updated to YouTube this week. And all the papers and all the documents, all the PPT we have shared will also be updated to our SGLang learning material. Thanks for everyone. Yeah, bye-bye.
I want to add one thing. We'll have our first in-person meetup in January with Hyperbolic, and we might also have another in-person meetup with AMD. The announcement will be made a bit later, but you can spread the information to your friends and just tell people that there will be an event and be prepared for it. We'll give a talk in the meetup about in more details about the techniques optimizations we've done in the past year, and hopefully, as people ask about pipeline horizon, hopefully we'll have some prototyping implementation for it at that time. So yeah, keep it in your calendar.
Pardon? You mean online meetup
in
or
person?
offline?
That would be an in-person meetup. So we'll have in-person meetup in January. Will be hosted in San Francisco if you live around. With Hyperbolic, which is our long-term sponsor, one of our long-term sponsors.
Yeah, and also more meetups with AMD, with NVIDIA, and a lot of companies. Yeah, that's it. Okay, enjoy it, and thanks. Bye-bye.